So yeah, my name is Talip. I'm the founder of Hazelcast project. I started the project 6 years ago in Istanbul, and in Turkish. So and then and a lot of companies started using it, and then big companies started asking for support, and then we found the company, moved the company to Palo Alto last year, and we did a round, and now we have Rod Johnson from Spring as our board member and investor, and also Greg Locke from Terracotta as our CTO. So we're now 22 guys and growing. Okay, so so the keywords we're going to talk about in memory data grids, clusterings, NoSQL, partitioning, and things. So these are the keywords. So why Hazelcast? Because we want to build highly scalable and available applications. That's who uses financials the most, and then we see telco a lot, and then gaming, e-commerce. So pretty much from a very, very small company to giants. So I can easily say most of the major US banks are running Hazelcast in production right now. Okay, so what is it? So you know HashMap, it's a key value store. It's not thread safe. You cannot share that map across multiple threads. If you want to, then you do what? You use concurrent HashMap. So now let's say, so what if you want to share that map across multiple JVMs? And then the answer is, you use Hazelcast. You get a map from Hazelcast. Now that map is shared across multiple JVMs. So as long as the names are the same, then you're actually working on the exact same map instance. And it's concurrent, and any JVM can update the map, and each JVM will see the changes. So I'll do a demo, a quick demo now. I started Tomcat already. I deployed Management Center. If you unzip Hazelcast, is it visible enough? Bigger. So in the lib directory, you'll see Hazelcast jars. Hazelcast all is the only jar you need probably, because it contains all the other guys. So and we have no dependency on any other project. So take that jar, put it to your class badge, start coding. That's it. In the bin directory, we have. I built a test application, command line test application, so that I can demo Hazelcast easily. So I'll run that application. But let's see what we have inside. So I'll open up. So it says what? Let me just close this one. So let me make that bigger. So it's actually starting a test app, command line test application, with this jar. So there's nothing else. Okay, so I'll run that test application. The Sage, run the Sage. Okay, so as soon as it hits Hazelcast library, Hazelcast will look around and see if there's anybody in the cluster, and there's none. So it says there's only one member, and this is me, so nobody else. So this is one member cluster right now. So it started at this address with this port number. So as I said, it's a map queue. So let's, if I do map.put 1 Seattle, then it's actually, so the command line will convert, application will convert that to map.put, right? So the name of the map is actually default. So if I do m.get1, I get the value. So is it enough? Let's make this bigger. Okay. And one, I got it. So if I start another node, and if I run the application again somewhere else in my network, so now it's going to use multicast by default and look around and see if there's anybody else in the network and join the cluster. Now we have 2-node cluster. and if I do m.get on from that JVM, I get the same value. So start sharing the map.
Are you going to talk more about the discovery mechanism and how it works like on EC2 or Rackspace?
Yeah. So let's. So this part is. So right now it uses multicast. If I open up the. Is that visible enough? Is it visible? Should I? Okay. Okay. So if you look at the configuration, join is actual discovery. So currently, multicast is enabled. So it's using the multicast right now. The other mechanism will be TCP/IP. So you list the well-known addresses, the cluster node IPs. So basically, when a node starts, if you enable this TCP/IP, the node will try to connect all these nodes, all these IPs, and try to join the cluster over these IPs. So you don't have to. You don't have, like, let's say you have 50 nodes. You don't have to list all the 50 nodes here. Just give us enough so that we can connect the cluster. It could be, but one of the nodes, one of the IPs that you listed here should be up and running so that we can join over that up and running node. So you don't have to list the entire thing. And let's say you started 5 nodes, you're running 5 nodes, and then a month later you want to start another 5. You don't have to list there. So you already have five guys running, and the new 5 nodes will join the cluster over these existing ones. So you don't have to update the XML. And XML configuration has to be the same on each node. One configuration for the entire cluster. It's not per node. It's one config for the entire cluster. So if TCP/IP is not enabled and multicast is not enabled, then you can turn on AWS or OpenStack or Amazon Web Services. So then you pass the credentials, access keys, and that way you don't have to list the IPs, or you don't have to list the nodes running Hazelcast. Basically, since we know the access key and script key, we'll ask the environment at Amazon Web Services to get the list of the nodes and try to ping them and see if there's any Hazelcast running there. So the whole thing is that, the main idea here is that we have to find a way to ask somebody or some guys if there's anybody in that any node, any cluster in this environment. So that's the so it could be a multicast message. It could be like pinging a couple of IPs, or it could be Amazon Web Services calls to get the list of the IPs and ping them. So that's the join part. After join, everything is TCP/IP. Everything is NIVIO. So when you do AWS, so basically you might have a lot of nodes running, hundreds of nodes running at Amazon, and you don't want to ping everybody, right? You can say, hey, only ping the servers at this region, or the host with this header, or host with this key value tag key value. So you're actually filtering, right? You're saying don't try to talk to everybody. Talk to the nodes with this specific information. Okay, so after we discover the cluster, we join the cluster. Now everything is NIVIO, everything is TCP/IP. Okay. Any question in the discovery?
This is like a config file. It's just picked off the class path or something like that.
Yeah. So basically, you can pass the location, or if you drop it on the working directory, we'll pick up from the working directory too. Or you don't have to use XML. I mean, you can use config API to configure everything. A lot of people do prefer config API.
So when a node joins the cluster, it gets the configuration from the cluster?
No, every node will have a configuration, but that configuration will be the same, exact same configuration for everybody. So it could be like a, you can put the configuration file into an HTTP server and give a URL, and everyone will pick up from the same HTTP URL and run from that. So, but or you put the XML file into the deployment, into your war year, whatever, and then as you're deploying your year or war file, it's running the exact same XML file. So either way will work. Which one would you prefer? How were you thinking to do it?
You were thinking no
Good,
XML.
because, it sounds like for nodes joining later, they can just ask what's the configuration should
But
be.
First, yes. So two things. We can definitely separate the config, the join part from the actual configuration of the maps and queues, right? So these are actually two different things.
Right.
So what you're saying, but you still have to have a common discovery mechanism, right?
Correct.
Okay. So or for our case, network tags should be same for everybody, and rest can be picked up from the cluster, right?
I
That's
don't
what
know
you're saying.
why it needs to be the same, because, some nodes might be joining by multicast, but there might be some other nodes that will just TCP/IP and join the same cluster.
Okay.
Why it needs to be exactly the same?
Because let's say you do have a different
Subnets. And,
different configuration for and then
Now, let's say I have two subnets, and multicast is disabled
okay.
between those two subnets.
Okay.
So nodes in one subnet can discover one another with multicast just fine, but if I want to run a couple of nodes on a different subnet, well, I can probably specify
Okay.
IP addresses of some nodes and.
The thing is that everybody should be able to discover the other guys in some ways, or most of the time it should be the common. So so you're thinking about the first time join, and you're right. Like if everything goes right after the join, like, life is good, nothing is broken. It doesn't matter how you join, right? So you join with the multicast, and then later on with the TCP/IP. That's fine. But let's say network splits, and then you have a network partitioning, and then now, so you want to make a decision on, you should be able to find the other guys, or the other guys should be able to find you. So that part is problematic because the methodology now you're describing is different. For me, I'm expecting that you're gonna scan the IP list, but you're doing a multicast discovery. Or the other guy's expecting something else. So expectations of the nodes are different, and that can result in different.
Because it'd be in a different subnet.
But then it gets super complicated to manage the cluster. I mean, it's not only first time join, but after that also, yes.
It's kind of on the same topic, so I want to get in there. What happens if you were to have more than one of these methods enabled?
Yeah, so, and you can, maybe that's, so you can say true here, right? Okay, so by default, Hazelcast will check if the multicast is enabled. If it is, then it will try that first. Then if you cannot find it, it will check if this IP is enabled. It will try that second. But that thing should be consistently the same for everybody else, so that everybody has the same kind of understanding of how to join the cluster. If they have a different way of understanding, then we cannot make a decision on whether there's nobody else or I just don't have the right information to look for them. You're just not able to make a proper decision on whether there's nobody else or you are lacking in information.
In my example, let's say in a second subnet, multicast cannot be used to discover the rest of the cluster.
But then
So-
it's probably not a good idea to combine these two. To me, everybody should understand, everybody should have the same exact expectation when it comes to joining or then being part of the cluster. Internally, it makes everything complicated. We cannot figure out, we're not able to say, this guy is expecting to receive a multicast message from me. So should I open my multicast socket? I don't even understand, because for me, I should not, because you only enable TCP/IP. So I turned off my TCP/IP server.
I understand you correctly. You said when we just specify a couple of nodes and everybody joins later, just know those IP addresses. It probably keep the list of the TCP/IP addresses somewhere and then does the peer-to-peer, right?
Yeah, and you don't have to update, even if you have new guys joining. The new nodes should not be in the list, doesn't have to be in the list. So what,
That's
to me,
right.
what is the most important is not the completeness of the thing, but the consistency of the information. Yeah.
So maybe it would help if you moved on to the subject of the network split, like you talked about.
Okay, yeah, that's.
How do you handle the network split, or let's say
Yeah,
I had 8 machines, and now 2 of them are still functioning from the 2's perspective, and the other 6 are still functioning from the 6's perspective.
yeah. So if you follow the CAP theorem, when partitioning happens, you have to give up on C or A. We give up on C, consistency, and stay available. That's our, so that means if the partitioning, network partitions to 2 and 6, 2 nodes will say, all right, we're just fine, we lost the 6 other guys, we're just 2 node cluster now, and we'll keep running, and we'll keep updating the entries, and we'll keep serving the queues and maps. The other 6 will say, we lost the 2 other guys, we're just fine, we're gonna keep updating the maps and queues. They're dead, and we're up. So each one of them will say, the other side is dead. So,
Okay, so do you have an option of switching to a mode that basically says, I want to have at least the majority?
not right now,
started with-"
not right, yeah, that's a different thing, okay. When you say a minimum number to start with, and we do have that, so minimum cluster size is a configuration option for us. So the cluster will not start until the X node is node started. So that's, but this is for the starting. But the question now is actually, should the 2 keep running, right? And that's so we don't support yet, but in the future we should be able to say, hey, if the number of cluster size is less than 6, stop serving, right? But again, that's a question of like availability versus consistency. So what are you going to do? So the clients are connected, and you're not serving anybody. So you're rejecting all the requests. The exception is thrown to the enclosures. So
Read only mode.
correct. Yeah, or read only. I agree. Even if you're reading, you might be reading the wrong data because it's already changed here.
So do you offer the?
We don't, but we
member-
should.
The member, current member count?
Yes, so you've been exposed as an API, so we say, so you can get Hazelcast get cluster, and then you can get the members of the cluster, you can count them, of course, or we give you the expose the cluster interface, you can look at the members. But currently, we choose availability and go with the, we keep serving the data structures right now. But I think there will be cases where you will need consistency more, and you'll say stop serving if the number of nodes are smaller than 6, for example. Don't serve anything.
So if the network is partitioned and data is changed for those halves, how do you resolve it with it?
Yeah, so then, of course, it's not grids or data grids problem that we didn't create the network problem, but we should be able to deal with it, right? So eventually, the network guy will fix the network problem, and then Hazelcast by default every 5 minutes will use the same discovery mechanism to discover the other nodes. And will actually say, oh, was I part of a bigger cluster? Right, so that's the question actually. Every 5 minutes, Hazelcast nodes will ask, was I part of a bigger cluster and I was somehow kicked out or got separated? So, and if it finds that there's another cluster, right, like another 2 nodes somewhere, they will merge. So smaller cluster will merge to the bigger one. And when you're merging, of course, data could be updated on both, right? So key 1 could be updated in both. We have to merge those. Per map, you can define a merge policy. We have built-in merge policies already, but you can build your own. We'll give you the key, the entries, and you look at the versions or update times or values, and you're going to make a decision. But regardless of how you do it, how we do it, this is a mess already. Like it's not a clean process. It's your even if I give you the values, like I can't give you the deleted ones, right? It's already gone. So I cannot tell you what's deleted. I'm not persisting what's deleted. So it's a best effort thing. Even merge policy is a best effort thing. Yeah. So
let me ask you a question. You said you can't tell what's deleted.
Yeah.
Because you do a hard delete. You don't do a soft delete.
we do a hard delete. It's
Okay.
gone. We don't. So
Because like you're
just
familiar with tombstoning, right? And Cassandra and stuff like that, right?
yeah. I mean, even for their cases, like I mean. So there has to be. I mean, if you really want to fix this problem, you build something else. It's not. So you can say, okay, so like you know this data center replication tools. Like if you're building that, so this is perfect example of that, because now you have to you have to have a time series database and keep all the updates somewhere. It's all the changes, and even have them version, and then make sure that these updates are passed to the other side, even after the disconnections. And so it becomes a different problem, and different. And you're solving a different problem. What we are trying to solve is like imagine a market data or trading application doing like thousands of updates per second. So you cannot store all these updates. I mean, it just doesn't make sense to store them on the disk so that you can replay them later on. We're staying away from disk so that we can be fast. So that's why it's like it's a best effort, and it should be best effort to me. For our case, not.
Well, so a system that addresses this same area, you know, and doesn't delete anything is Datomic, right, which is based out of Clojure's immutable maps, which you could run with the same sort of logic here.
But they're already disk-based database.
No, they're not. They're a key value store. They don't care. You can be totally in memory with Datomic.
But then you have to keep all the versions in memory.
Well, they never delete, right? So the way they talk about it, there's two separate processes,
Okay.
and there's an index process, which is the guy who has to go through the logs. But normally, you never see, you don't ever have to look at them. You never look at the history. You only look at the current map.
I mean, so just explain this. So I'm updating the map, let's say 50,000 times per second.
Right.
How do I keep all the changes in memory right now? I mean.
No, the changes don't have to be. They don't care. That's the log does not need to be in memory at all. It can trail along in whatever, you know, you can buffer that as much as you need to.
Where do you store the logs?
They do have to wind up on disk eventually.
Yes. So if you do, then we cannot give you the in-memory speed, or we'll give you, it could be like a write-ahead log, kind of like very fast, just a append-only kind of
Right,
log.
it's purely append. There's no,
Yeah.
there's only appending. There's
Just
never
write
anything
to,
else.
write to def null, it's really
then
fast.
it becomes, like, as I said, like, now, if you tell me to fix this problem, I fix it this way. So what I'm saying is this, we're not trying to fix that problem. So maybe Atomic or Cassandra or other solutions are trying to solve this problem, and they have exactly that, right? They're like append-only the disk-based persistence, and they can do that. But what we're trying to do is like serve you all the data from memory. We're trying to optimize memory, and we hardly care about the disk. We don't even provide you persistence at all. But we promise you that we're going to be doing it fast, and everything will be in memory. So that's But this is like the general lesson from all this discussion to me is that, like, if you come to me and say, hey Talip, just go build a super fast cache-only solution to me. Like, so my design, my code will be entirely different and it won't be Hazelcast. So you tell me what you want, and design and requirements and everything will be different. So if you tell me, hey Talip, go fix the data center, the replication problem, everything is different. So we're not, Hazelcast is not a solution to everything, at all, not at all. We're not claiming to be. We're just saying, this is the tool, these are the capabilities. Just as an architect, see if you can utilize and take advantage of it. That's the whole thing. I don't think, I mean, in any of the NoSQL databases or any of the guys claims to be this solution to everything, right? So every one of them has goods and bads. That's why they're different columns based and document based and high latency, low latency, memory disk. So all different. So yes, we have to do a lot of learning, and then we have to understand what to use where. So I agree, the network can be separated from the rest of the config, and actually this is proposed for. We'll work on that. Okay, so where were we? Yeah, okay, so we were doing a demo.
Question on your demo. So when you go in and do a put, are you doing basically like consistent hashing, and that's actually going just to one of the JVM processes?
Okay, so very simple. When you do a map.put, you take the key, hash it, mod with the partition count that we set initially. It never changes, so you set it once. And then we come up with a partition ID for that key. And every JVM has a partition table, tells who owns which partition, okay? And then for a given key, we find the partition ID. From the partition table, we find the owner, and then we take that invocation and run it on that owner node. So owner of the key will run the operation, put or get, always. I mean, there are so many key value stuff out there, and a lot of them provide you different guarantees, and you have to be really aware of that. So, for example, I mean, how consistent are they? Like, this is one of the biggest questions that you have to ask. The second one, what's the replication mode? Is it synchronous, asynchronous? Because if the default is asynchronous, so you're going to see that, oh, this is super fast. This is double or faster than this and that, and you're looking at the totally different wrong thing. There are a lot of solutions out there, but the guarantees that they provide, they give you, are quite different, and don't be tricked.
So to clarify, that your data is sharded across all of the
Correct. If you have
cluster.
10 million entries and 10 nodes, each node will own about 1 million record. right? Store 1 million.
So it's not redundant, so if one of the nodes crashes,
And then, based on, per map, you configure a number of backups. And default is 1, and it is synchronous backup default by default. So by default, you're going to have another million on that node. So I'll show you in the demo. Yes.
So just to be clear, with the default configuration, a distributed object would end up on 2 nodes in a cluster if there are at least 2 nodes.
Correct.
Okay.
Okay.
So is it always network? Yeah. So if it's a sharded, so if so let's say
Oh.
key 1 belongs to a different node, then
Mhm.
always.
You always go to the owner. Always. Even
So
for the
there's no
reads.
near cache.
You can. If you enable, then it's a different story. So by default, there is no near cache. There is no, it is all synchronous. You always go to the owner. But Hazelcast has a near cache feature that if you enable, then the caller will cache the missed entries. But you
Who will
enable.
update those?
Say it again?
Who will update those?
Okay, so near caches will have either TTL or if you set invalidation, invalidate on update true. That means the owner will push or broadcast an invalidation message to the endpoints and get them invalidated. So regardless, there's a tiny little bit of chance that you're gonna read stale data from the near cache. Whenever you say cache, you're actually implicitly saying that yes, it is possibly a stale data, but that if you're fine, you're fine. So, but by default, Hazelcast will be consistent and you won't read from the caches or found the replicas. So all these things are features of Hazelcast. Like we can enable reading from the cache, reading from the replica. But by default, it won't allow you to do that. You can set up an asynchronous backup, but by default, it is synchronous. Okay, so I'll do more. So let me do more. So we extended the map so that we can provide things like locking. So if I lock the key 1 here, if I try to update 1 from another JVM to New York, let's say, I won't be able to because this guy has a lock on the key, on that particular key in that map. So
What happens if that node dies while
Okay.
holding the wall?
okay, so which one do you want me to kill?
The one that holds the wall.
So this one, right? So this, if I kill this one, what happens? So these are the questions that scares the demo guy, right? So, okay, let's do that. All right. Okay. All right, I did it. All right, I got it. So it's actually went through. It was waiting on the lock on the put, but now it's like it's there. So let's see if the value is actually there too. New York. So the owner of the lock, when the owner of the lock dies, all the locks belong to that guy will be released automatically. So, but of course, I made it look like I was scared. It always works. It always works. So let's start again. Actually, okay, yeah, let's start again. I was going to show you a lot of this stuff, but
Don't let him slow you down.
okay. But that's good. Okay. So if I add a listener, I can add a listener for that map. So this guy is listening for the updates. If I put something else, then of course this guy will get notified. So you can listen for the you can lock the entries. You can listen for the updates for that map. You can listen for a particular entry too, or a particular filter. Because if the entry matches that, notify me. The queues. Okay, so let me do more. So let's see how our monitoring system is doing. So we have these guys. So let me put more. put many thousand entries. So I got notified, that's fine. So let's see if you have 1,002 entries eventually. Yes, you got it. So as you can see, like this guy this member is owning, is it big enough? Should make it.
So a quick question.
Okay.
Quick question.
Okay.
I understand that there's an enterprise version.
Uh-huh.
Can you let us know if you're showing any enterprise features at any point so that we know just
Okay.
what we're seeing?
Okay, so I will. Okay, I'll do that. So this guy owns this many entries, this guy owns this many entries, and this is backed up right here on that node, and this is backed up here. So we have the backups already, so we know how data is distributed right now. We see it. So I'll start the third node and see how things change. So eventually, hopefully everything will go fine. Third node will pop in. One.
There you go, enterprise feature. You activate error. License. Yeah.
So I think that's a premium.
Okay, so I'll create a license key from us.
Excellent.
That's not hard. I can fix that problem. Okay, so go away. Okay, so let's see. Nice. 3 nodes. We got 1,002. So, but let's look closer. Like, okay, these guys are equal, which is good, right? The backups and the owners are equal. But, so it's not the same anymore. Like, this is not backed up anymore. Because we're not really backing up to another node. We're like, so some of these guys are here, and some of them are here. So while we're actually backing up, we're actually backing up in a balanced way, so that when this guy dies, these entries are going to be owned by these two, and it will stay balanced. There is no need to rebalance again, because we already backed up or replicated to the other guys in a balanced way. So we're like.
Let me ask you a question. So if you lost node 2 right now entirely,
Okay.
you wouldn't still have all 1,002 though.
Okay, so let's do that. 2, where's the 2?
Or
So
whichever
this
one
guy
you
is the
pick
2,
around.
right? So this is the second node here. It says this.
Okay.
So I'll kill this. And then let's see. Let's see. Demo. I guess
It's
it's
less than 1,000.
Okay, let's see.
Oh, no.
Yeah. Got it. So everything worked just fine. Okay. What else? Okay, let's play with the queue a little bit. So queue.take is a blocking. Oh, it's not the. It's dead already. Okay. Queue.take. So it's waiting on the queue. There's nothing in the queue, so it's waiting. So but it will wake up as soon as we offer task. Right, so this guy just got it. Okay, so the queues are just like blocking queue that we know from Java, but it is shared across multiple JVMs. Okay, so that's let's go back to the presentation. So anything you want me to do?
What will happen if 2 nodes take, but there's nothing?
For
So
them
2
trying to
expecting something from the queue.
Okay, let's do that. SH run SH, third node is coming. Okay, and then Q.take, so this is waiting here. Q.take, this guy's also trying to take. So obviously, if we offer anything from here, so they're both, these threads are, the calling thread is now blocked. Everything else is running. There's nothing wrong with the other threads, but just the calling thread is blocked. Task 2. So obviously, what do we expect? We expect only one guy to take that, right? Of course. And this is now this guy took it, right? If you offer another one, guy took it. So imagine a scenario where one of the JVMs will be putting things into the queue, and you have 10 other JVMs consuming and processing and consuming and processing. It's very simple. You can do it with the JMS. What we're saying is 99% of the time, this is what you need. Why do you care about JMS? All right, if you need more guarantees like persistence in the queues and things, then you go deploy your favorite JMS and use it. Yes?
Are you going to talk about serialization
Okay.
at one point?
I will. Okay, so I think this is good. So let's move with the presentation so that we can talk about other stuff. Okay, okay, so data grids. We have all these guys also in the market. So you probably heard some of the guys. So they're all good. There's nothing wrong. I like all of them. I just like Hazelcast better. That's it. So different license, cost, feature set, API. I mean, essentially they do the similar thing, but quite differently.
Since you were talking about alternatives, what happened to Jini and JavaSpaces, and why Hazelcast now, and what happened?
JavaSpaces, how old are you?
About how we're in the 20th year of Java now, and I remember, yes, I was excited about this stuff 20 years ago.
Yeah, I was too. So I built a JavaSpace implementation called JPower back then in 2003, and I was a big Jini fan. But I mean, Sun was failing to market it nicely, and it wasn't attractive enough to a lot of developers, and eventually became like a a niche developer tool, and only like 1% of the people care. So that, I mean, I loved it. I loved all the discovery mechanism, pushing the interface and lookup mechanism, right? And all that stuff is like so brilliant. Like pure service-oriented Java. You got it all there. So it's just amazingly designed, but it's so hard too. Like because it never became the platform. It was always became like a platform here. There's a big giant J2U world, and everybody's trying to build application with that. And some people try to bring Jini into J2U, and then they created a bigger mess because now you're running a platform inside a platform, and it's just complicated. Just like it's not nice. Nothing not nice about that. Eventually, so when you look at what people want, they actually want really simple things. And they don't want to really they're really good developers, and they're smart. They want to innovate. They want to always work at the edge, right? So we always have that 1%. Always, they always try to use the tools that nobody else uses, right? They love being like that. Some people can refer to them as hackers, right? And I was one of them, so nothing wrong with that. But I mean, eventually, we have to, look at what the world is going, and you have to somehow align. I think they missed it, so they missed it big. I don't think they will come back anytime soon, because now people hate containers. People hate application servers. They just want to run simple processes all over the place. They want light stuff. Even Spring now, it's not light enough, right? Now it became a giant thing. So it used to be, right? It used to be the light thing. People escape from J2E to
Spring Boot.
What is it?
Spring Boot. That's their new little mini container.
Oh, really?
Yeah.
Yeah.
I don't have an opinion of it yet. I'm just saying they're trying to shift as well.
Okay, so no Jini anymore. Simple APIs, and no more like teaching a different API. if there's an API that everyone knows, let's try to use it. That's how Hazelcast started actually. We looked at the concurrency package and said like, hey, we can make all these guys distributed, and then developer can pick and choose to build their own distributed applications. Eventually what you need is a data store and a processing unit, right? If you look at the class, what do you see? Fields and the functions. So if you can come up with the distributed data types and distributed processing patterns like MapReduce and executor service, you can build your stuff.
That maps that looks exactly like Terracotta. Terracotta would do the same thing, except they, instead of saying Hazelcast, give me a map, it's an configuration file that's...
Are you talking about the DSO? Like
Yeah.
old Terracotta stuff?
Yeah.
That thing is dead right now. So it's not, they're not doing anything about it anymore. And when I first said 6 years ago, when I said like, hey, I'll build a different distributed implementations of maps and queues and this and that, I got the first comments I received was from Terracotta guys. What are you trying to do? Are you trying to do similar things like Terracotta? Like, because DSO was the big thing for them back then, not anymore. But so what I mean, I think Terracotta DSO stuff was very cool. I mean, extremely cool, but had its own issues. Like it was hard to use. You have to change JVM stuff, and
Is that their off-keep?
no, the DSO, the old you say they.
This, basically, in the configuration
Yeah.
file, they get an aspect or something and say, this map is actually a distributed map.
Yeah. Yeah, they store the
And it works
content
exactly.
of that map somewhere else. And that way they can share the content of the map with other JVMs. Or any object. It doesn't have to be actually a map anymore. It could be anything. So it was cool to me, but people need, I mean, developers do need simpler things. That's why Node.js kind of stuff is so cool. MongoDB's, by the way, simple doesn't mean high quality or the thing or the solution. It doesn't mean, it just means it has a high probability of getting a way bigger adoption. That's it. So right, if it's simple, you can get adoption is quicker.
Well,
It doesn't mean that it
case
has
of
a,
G2E is kind of opposite.
Yeah,
They never were simple, but adoption was kind of high.
it was pushed. So they could have done the same thing for Jini. Anyways, so let's move. So Hazelcast Apache license, 2 megabyte jar, does maps and queues and things. We expose the clustering API. Use cases, you want to share data, you want to share session, for example, you want to share, you want to store more data and process more data. You want to do messaging and things. So this is basically what you can do with Hazelcast. So where's data? We talked about it. We partition and we find the partition ID from the hash of the key, and we mod it with partition count. And then all this member in the cluster will assign, will make will update the partition table. And if when a new node joins the cluster, old member will say, hey, I'll take this partition from these 2 guys and give it to the new guy. So that's usually, this is basically what happens. So we call, and the partition will move. We call this migration. So when a node is, new node is added, partitions will start moving, migrating to the new node, and the backups are also taken. And then when the migration is complete, so everyone has almost equal number of partitions and almost equal number of nodes.
But if you're just doing like a hash modulo and you add one additional node, wouldn't that result in like
No, because
data moving all around
yeah.
the place?
First, so for a given key, we know that partition ID will be exactly the same regardless, correct? So that never changes. Doesn't matter how many nodes, because we don't care about the nodes. We care about the partition count. Partition count is not the member count. Partition count is a fixed number that you set when the cluster starts. You don't have to set. It's by default 271. it never changes. It's not member count at all. So for a given key, it's always the same partition ID, and all this member will assign the owners of the partitions, and everyone knows that. So everyone knows who owns which partition. So no crashes, and then backups are owned, and we store the backups, and blah 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 blah, all safe. So you saw that in the demo already. So this is how it happens.
Well,
I'll pass that
happens
to.
quickly for the small data set, but let's say
Okay, yeah.
it's a big data set.
Yeah. So we're working on. Okay, off heap. We're working on off heap. Off heap means stored 100 gig on a per node, and then store terabytes of data in the cluster. Right. That's what we're trying to do. So we're investing a lot into off heap. So that brings that problem, right? So how do you then migrate a big chunk of data to another node, right? So this,
And what happens to the request while you do
yes. Also, what happens if you're doing a put during that migration? Migration is like, even though it's quick, but still, it's not. It's just taking microseconds or milliseconds. It's taking seconds. So the answer is actually very simple. So you remember the partition count? So you can set the partition count to any number. It could be 5,000, right, or 10,000. So by doing that, each partition the size of each partition will be like tiny little thing. So even if you have 1 terabyte data, or 10 terabyte data, and even 1 billion entry. So by adjusting the number of partitions, you can even calculate how big the partition will be. So you can say exactly how many megs partition will be. And then the good thing is that when a migration happens, we take all the data in that partition, we zip it, and make it like 20 times even smaller, and then ship it in once, and then unzip it and put it into the node. So it's actually a pretty efficient model. So the key here is that you can adjust or can set a much bigger partition count. And for the bigger clusters or bigger, if the entries are like hundreds of millions, then you set like 5,000 partition count.
Okay, but still my question stands.
Okay,
So let's
doing
say-
that, what happens, right?
So here's a scenario. Node just died.
Okay.
So now, and let's say backup, there was only one backup somewhere. Okay, now it will be active, right? So if I do the put against the data in that particular partition, so will it happen on the node, or it will wait till Hazelcast will create the backup someplace else?
Yeah. So when a node dies, you already have a problem. If I try to fix fix that problem, I'll create another problem for you. You're already in a bad shape. You lost a node. So the way Hazelcast deals with all this stuff is that when you do a mapped output, there's a internally set seconds that I will wait for the backup to return. Even though it's synchronous means that if everything is just fine, if the cluster is in a normal state, I will wait until the backup says I got the entry. Now you can return. But you already lost the node. You lost the backup too, maybe. Then you're going to wait the guy to take a backup first and then apply the put operation. So do you really want to wait all that stuff? So the answer is actually, so we set a 10-second by default. So if that happens in 10 seconds, you're fine. You will return. If it doesn't, you will say, you know what? Looks like you're in a terrible situation. I'll return anyways. I won't wait for the backup to be taken because you're in a terrible situation right now. And so what does that mean? So that means the backup is not taken. But you have a good reason, because you're not in a good shape right now. But eventually, when the guy is ready to receive the backup, it will get the entire partition in one shot already. So the backup will, the missed backup will be part of the partition already. So what I'm trying to say is this: the backup node, when the backup node is feeling good and ready to take the partition backup, it will initiate the call and just grab the entire partition in one shot. But I don't really have to rely on the backup node when I'm doing the put, because it is very possible that the backup node is not having a hard time, right? Or it's doing a lot of work, like taking a lot of backups. So waiting 10 seconds, or you can set it to 30 seconds if you want to. It is a solution. It's easy fix to escape from this problem. It's not. So the primary goal is not. We don't want you to wait forever, and we don't want you to wait because one guy is trying to take a backup. So backup is a secondary thing. It's not the primary thing. Primary thing is doing the put, and making sure that the entry is stored. So that's why so even if the backup goes out of sync, it's okay. The backup will say, hey, we have different versions. Give me the entire partition in one shot. I'll garbage mine. I'll take the original partition.
To clarify, so let's say there were 3 nodes, now there are 2.
Yes.
So I'm hitting the node.
Owner. Okay.
Now that had the backup, but now it's an owner of the data from the 3rd node.
Correct.
And let's say there are 2 calls. One gets to the data in a partition that is in the process of being transferred someplace else.
Yes. Okay.
And another to another backup partition that now is owner of the data, but it's kind of waiting to be transferred.
Or
both calls are penalized, or
okay.
only one?
Okay. Only if the target. So if I'm the owner and I'm my backup is not in sync with me right now.
There are no backups yet.
Or even there's no backup yet. I will return. The call will be completed immediately. So I'll take I'll accept the put and say I'm done. So you can return. But if there's a partition in me that's migrating to you, for example, and somebody else is calling, I'll say. So that means in flight mode, right? So right now partition is moving, migrating. So I'll say, do it again. So doing it again means this is internal, of course. Doing it again means there is a mismatch or migration happening for that partition, and you have to wait. So I rejected his call, and either his partition table will get updated, or my partition table will get updated, or migration will complete it and your partition table will get updated. Eventually he will know the exact final owner of the partition. And so he's gonna call you directly this time, because I didn't answer. I said like, go do it again, because the partition is migrating. I cannot do anything. So during migration, nothing can happen. No update can be done.
So when the client's making an update, is it only talking to the owner?
Always.
But
Reads,
only, so you don't,
reads are going to go to the owner.
Right.
Reads
So-
cannot be read from the replica.
Right, so it doesn't do things like concurrent updates to the backups or
No.
anything? Is there a replication beyond just, how much replication is there in the backups? Can you only have one, or can you have more than one?
So per map, you can define number of backups.
Okay.
One map can have no backup, the other one can have 2. And one map can have 1 synchronous and 1 asynchronous backup. you define per map how the backup is going to be handled.
So
Yeah.
it seems to me that if you look at your algorithm, when you add a node to the cluster, it is likely that every partition is going to have to move. Or most of the partitions are going to have to move because it's modulo the number of partitions.
No. Okay. Okay.
Any more partition than you have nodes.
Oh, okay, so that.
Only one end of the partitions will migrate.
Okay.
Because you're rebalancing, right? So if you have 10 nodes and you are adding the 11th one, 1/11 of the partitions will migrate to the new
Okay.
one. It's two balanced things. So and that's not going to become like a sudden thing. It's like a one partition at a time thing. It's not like ooh, let's do it all, because we don't want to. Because when you're migrating, the operations are not going to be completed, right? So during the migration, no operation can happen, no update can come in, no reads can happen too. Because we don't know the latest and greatest version of the data right now. It's just in flight. So there's something going on with the partition. Yes.
Well, that was encouraging what you said with 1/nth of the data will migrate. That reminds me of what Cassandra does. The thing I didn't quite grasp was you were talking about the when you're you have to calculate the number of partitions beforehand. It's a fixed number, and you kind of have to do that in anticipation of the maximum amount of data you're storing.
Because Hazelcast doesn't repartition, it's just rebalancing the partitions across the node, right?
Well, I guess the follow-up question to that is, what happens if you have, can you do a live repartition?
You don't, and we should.
Yeah.
We don't.
So you have to,
No.
but you can unload, you can serialize and come back or something like this, right?
Yeah. So I mean, I don't think we'll fix that. I mean, so 271 was good number because we were expecting like 10 nodes or total of 10 gigabyte data. So now, for example, newer versions of Hazelcast will have 5,555 partitions by default, because we're now seeing bigger data store and much bigger cluster. So by setting that to a high enough number, you eliminate all that discussions. So you don't have to think about restarting the node or any of that stuff. We know that partitions are going to be tiny little things.
You're trying to get it to a number where the number of nodes won't exceed it.
That would be a problem.
I think it's more than that. The number of nodes should be a fairly small fraction of the number of partitions.
Correct. Yes.
Can you set TTLs on the data?
Can you
TTLs?
On the data?
For the entries?
Yeah.
Yeah, I mean, you can set it for the entire map, or you can per put, you can specify TTL per entry.
So what's the reason not to just constantly increase that? It seems like every time you increase the partition count, the situation gets better, right? Block sizes are getting smaller.
That's why in the newer version we're going to set it like
why not 5 million? What is the downside of too small of a partition?
Every node has to track all the other nodes from the partition.
Yes.
Partition table get like the object becomes a bigger object that the oldest member has to recalculate and push it to everybody.
Yeah.
It's not giant work,
Yes.
but it should not be 5 million. It should, thousands are fine. I mean, but it shouldn't. Millions are a little funky. It becomes a big giant object. Broadcast it.
I just want to check it's half an hour left, so I just want
Yeah,
to make sure we
sure.
hit everything we have to hit.
Okay.
So.
Yes.
One question, so when the data travels, but I didn't quite catch it, when the data travels between nodes, is it like secured in any way, like through SSL, or is it just open?
Okay, so security only applies, it's like you can enable security and say, only these guys can join the cluster. So you can, or these clients can connect to the cluster. So these are part of the security framework that we provide. So that's done, but it's not about migration of the data. So you're either one of us or you're not. If you're one of us, we can do anything. We can migrate things and we can share data. But are you one of us? That's a security question, and we take care of it differently.
You assume secure communication between nodes.
Yes. I mean, you either enforce it with the configuration and things, or just security that we provide. So otherwise, we're going to say everybody's fine, or anyone can join, or anyone can connect.
You don't have like a pluggable transport mechanism where you could say, oh, use SSL socket instead of the normal.
Oh, Hazelcast by default supports SSL anyway, so you can just, it's just a parameter. Like you just say turn true, and that's it.
I was just wondering if someone was sniffing and grabbing some of the data as it's going.
Yeah, for example, that can take care of that. So you can run the nodes with SSL, even clients with SSL, then everybody's talking SSL.
As long as it's not open SSL from.
So yeah, that's right. Jazz security stuff. So let's go and just take a look at some of the codes. We used to have static methods like Hazelcast getMap, and we're running away from that, and we're using instance so that we can start multiple Hazelcast nodes in the same JVM. So you can, in a JUnit test, you can create a 5-node cluster and test your stuff. Kill the nodes and see if you still have the data. So it's pretty handy. So all object has to be serializable. We heavily rely on serialization. The objects should not be themselves serializable, but somehow they can be serialized by some other thing, right? So either they are serializable, or you provide a serializer who can serialize your objects. Okay. So serialization actually the biggest pain in distributed computing. I mean, it's not the network. Network is super fast. What's slow is actually the path to the network. So all the way from your call to the socket is very slow. That it doesn't matter how fast the network is, and it is pretty fast, by the way. 10 gig networks are super fast. You cannot even process it as quickly as you can read from the socket. But your path to the socket will be super fast, super slow. What the primary reason will be the serialization. The second reason will be, funky enough, the concurrency. So because your call is probably going to hit a queue and then hit a synchronized block and wait on a response block and things like that. That's going to kill you. So that's the real problem. So internally, we do our best to take care of the concurrency and all that stuff, but it's your duty to take care of the serialization. We'll help you to make it faster. So try to use data serializable if you can, or our portable serialization mechanism, which can serialize from C++ to Java to C#. So all that good. So to try to fix serialization first. So as I said before, we expose the cluster interface. You can get who you are, or you can get the member list. And that member list is actually exactly the same on each node. So for example, the very first member is actually the same on each node. So if you can do things like, if you are the first member, do this, otherwise don't do it. Like if you want to just one member to do some certain task, you can say, if you're the first, do it.
You're saying that that's an ordered set?
Yes. I mean, when I say ordered set is a little like a different term, but we are talking about the same thing. Just the order of the members.
The iterator will be the same.
Yes. So this is a distributed map, basically. This is like concurrent map. You can do puts and gets and also prefabs in place all the atomic operations are supported. Queue, the blocking queue, so you know the interface, take, over, pull, all that good stuff. Distributed lock. Try to go with this one because this is global lock and you have to manage the locks yourself. You have to deploy when you're done with the global lock. As you can see, it's get locked from the Hazelcast. But this one is like creating a map and using the locking entries in that map. And this is more efficient in a way that if there's no value attached to the key, if you unlock the entry or the lock is like auto garbage collected. So it's in this case you have to, when you're done with the lock, you have to destroy it yourself, which is not nice. Here, no value attached to the key. Unlock will garbage collect the entry. So, all right, topic, just like JMS topic, anyone can publish, anyone can publish, and anyone can listen, message listener, and we'll pass you the message like that, and you'll process that. Don't block this. This is our thread, so we're going to call this one from our thread. Do not execute or process the message here. Take it into your executor service thread pool and do it there. Don't block us. Same goes for the map events and queue events. We'll call you when the map is updated. Do the processing somewhere else. Don't do it here. Because we're using one thread to notify the listeners. Executor service, just regular Java executor service. You create tasks, right, callables, and then you can say, hey, please guys get executor service, and then submit the task. It will run somewhere in the cluster. So and you can attach a callback, and so that you can get called back.
If I understand correctly, then it needs to be available. The
class has to be available on each JVM. Yes, we don't just ship the class. JVM, the classes should be in the class path of each node. The same goes for the map entry processors in the map. So I'll come to that.
Is it possible to have members with a different class path? So let's say fixing some problems.
If the serialization is the same, you don't care. You don't even understand, right? If I can serialize from one node and the new JVM with the new new classes can deserialize it fine, that means the serialization of the task didn't change. Then it's fine, right? But if it did, then you're going to get the serialization exception. This is a big issue, by the way. Anytime you talk about distributed calls or distributed execution, this different versions of the classes or upgrades of the classes or application becomes a big discussion. I think this is going to be discussed for.
Grid game does that from the
partially.
beginning.
Partially. It can only fix the one class. If there's any dependency, just I don't think it's a production thing. It's just good for testing. I don't think they recommend for
Gemfire is a production thing.
Okay, I'll check. Good stuff. Nothing. Yeah.
Due to the serialization issue, do you know if any of the customers are doing their own serialization, like with JSON or something like that?
Oh, they do. They use JSON. They use Cairo. Cairo is a big. What is it called?
Cryo?
Cryo or Cairo or Cryo. Yeah, Cryo. Okay. Cryo is a very famous one. Protobuf. Protobuf is another one. They use a lot. So we do have a pluggable serialization actually. You say, here's my serializer.
Is that what that interface was that you said? Extending
No, that's one of the things that we support. The data serializable is our thing. But the cluster wide, you can say, this is my serializer, and we'll pass every object to you, every byte rate to you, and you take care of it. Yes. So you got the task, and then you can say, hey, run this task on this member, on these members, or on this key. You can say, take that task and go to the owner of the key and run it there. Why would you want to say that?
That's where that object is.
Say again?
That's where that object is.
Your value is there. The data that you're interested in is there because of the key. Yeah. So let's say you want to remove an order from a customer. Customer object contains an order. And let's say your business requires to get a lock on the key first, so that no one can touch while you're updating the customer. It doesn't have to be this way. You can remove lock and unlock, and everything will be fine. Everything will be concurrent. Everything will be just fine. But let's say your business is so strict that it's like a transaction that while you're updating, no one should be touching it. So then what do? You lock the entry first. You get it, you get the customer object, you update the customer object, you put it back and unlock. So it looks good, and it will run. There's nothing wrong with this. But it's not efficient, it's not good. Why? Because you're doing how many calls? 4 network calls. And also plus the apps. So how can we do it better?
Optimistic locking.
Run that on the node that has.
Correct. So that's so we follow the context or the presentation logic. You should be saying that, right? So run the task on the node that has the customer object, right? So this is now becomes a task to update the customer, the order, and then it's partition aware, meaning it will go and run on the customer ID, right? These guys will say, oh, it's partition aware. I should pick up the partition key and take this one, go there and run it there, right? That's and now your logic is different. So we're going to say get executor service, create a task, and submit. So that's different. Now, still, so your task will go now the benefit is that some of the operations will be local. Backups are still remote, but the owners are local. But also, little tiny bit of data just passed to the other node, right? So because order completion task contains only the delta, only whatever you want to change. So you don't have to grab the entire customer object, which could be big, and then put it back, which could be really painful, right? So instead, you're just saying, I have this delta stuff, and just go there, run it there, and come back. So this is better than the other one, but
is there a way to know if you screwed this up and got the wrong partition key, it would still work, right? I mean, you executed on the wrong guy, the wrong node executes it.
How can this?
Well, if you just put in there's another get partition key, if I return the wrong value for where the partition is, then wouldn't it still succeed? Because
it will.
So is there a way to know that you screwed up and it's just running a lot slower than it's meant to be, right? Because you're actually running it on not on my box, but on someone else's. It's the wrong node.
Correct.
It's putting it across the network itself. There's no way to know. Right?
No,
you got the wrong variable.
We're assuming that you coded correctly. We're assuming, but it's
fortunately, programmers never make mistakes. So
eventually,
Well, but if you're using the same key, right, it's partition aware, and you say.
Yeah, I mean, it should not be wrong, but I mean, in practice, it's going to be wrong.
It will be.
There's no way to profile it and figure out that it's wrong.
Correct.
You're just going to run it
and it will run, and you won't notice.
Exactly.
Correct.
That's the thing, right? It will work either way.
It will just fine.
Send it any way you want.
But can we do it better? It's still painful because like you gotta get a log, and it is possible that while you're doing that, the partition was there, but it just moved, right? Right? You feel like.
So then you'd run it in transactions. You could cancel and redo.
But, so even if the partition migrates, it will still succeed. There's nothing wrong.
Right.
But it's still not the optimum case. Like this is not nice. Like, so it could have been better. Like, if somehow I can say, hey, run my thing without the locks. I don't have, give me an implicit lock and make sure that while I'm running that thing, don't migrate, right? If I can say that, this could be super cool, right? And then everything is guaranteed. Locks are gone because it's the Hazelcast will give you an implicit lock, and then guarantee that it won't migrate. It's beautiful. So this is called entry processor for the maps. So instead of writing a task, you can write an entry processor and say, run this entry processor on this key, and we guarantee that you got the lock, and you don't have to lock. You remove the locks. There's no need. We'll give you the entry. You don't even have to get it because we give it to you. And you just do your update and just get out. So that's not. You don't have the code right now here, but you don't remember that. This is a super powerful concept because we guarantee that its entry is yours. No one can touch it, and it can't even migrate.
I'll repeat what I mentioned about Datomic, which is, this is how it works, which is the piece of code that you give it is the update you're going to do to, which is a item-potent update to the key value. And so you give it that little piece of code, which is just a little, little closure or whatever, and that's what runs on the machine that's going to do the write.
Nice. So looks like.
Yeah, you really need to watch Bertucci's design of Datomic. I mean, it's like super cool.
So Datomic is built by the guy who.
Well, he invented Clojure to create a system that would be the ultimate concurrent distributed system that scales to any size, and then built Datomic on Clojure.
Yeah.
But yeah, so you can incorporate, you can steal his ideas. He gives them away for free, so you can put them right in here.
Okay. So persistence. We don't persist anything and end up the discussion, right? So, but we can call you to persist things. At the owner nodes, as the updates come in, we can call you to persist the entries. So for that, you don't have to, but if you implement map store, map loader, then when you do a put, we'll call your implementation store method to store it. And it's up to you to store it anywhere you like. We don't care. You can choose, you can connect to a MySQL or MySQL. It's a nice thing, like MySQL and MySQL. So I like saying that.
It looks like you don't care so much that you don't care if save was unsuccessful.
Oh, we do. We do care about that part. So if you throw an exception, you throw that exception onto the put call. So you want, and if you're doing that inside a transaction, your transaction will fail. We do care that.
Then, it would be me personally, I would prefer to see that you expecting some exceptions and it works.
It's really, that's really.
Semantics, and because looking at that, I will be scratching my head.
It's actually a guy who loves Jini should not say that, because like all remote exceptions are all over the place in Jini.
Yeah.
They explicitly
I
say.
have mixed feelings about myself.
And each method has like a four exception that you have to catch in Jini.
Yeah, but in this case, well, if you put our mouse we wanted to handle exceptions, then having them as a part of the signature would be.
Yeah, but it's now part of, instead of being part of the signature, it's part of the documentation.
Most people don't do this.
You can always catch the runtime.
15 minutes left.
15 minutes left, so that's true. So it's actually, we're doing pretty good. So when you do a put, we'll put it into the owner, put it into the backup, and if it is, if you have map store, we'll call you to store, and then come back. But if it is right through, which is synchronous. So you could also have a delay for the writes. So then it comes right behind, asynchronous. So in a configuration of the map store, you can say delay seconds, write delay seconds. And if it is, let's say, 30 seconds, it means you're using right behind, not a right through, synchronous, right behind. That means when you do a put it into the order, put it into the backup, mark the entry as dirty, and just return, right? And then 30 seconds later, flush the records and as a bulk, right? So if you have 1,000 entries updated, I'll give you 1,000 of them, and you do one database call to just flush. So which is very efficient. Databases will love that, right? So they love bulk operations, and that means you're not calling the database all the time. And also, if database is not available, that's fine. It's still dirty. So when the database comes back up, we'll flush everything in one shot. So that means we'll keep serving the data, we'll keep updating the entries, we'll keep marking it as dirty, and then when the database is up, flush. So and you can, for one map, you can flush it to MySQL. For another map, you can flush it to or store it to NoSQL, or you can flush it to Elasticsearch for searching panes. So basically, it becomes like a operational data store that you can eventually flush to anywhere you like, anywhere needed, right? So, but now you keep talking to the data. Data is available for you all the time, even if the other guys are not available right now. Yes, but of course, when it's asynchronous, that means you're taking a little bit of risk, right? What if the owner and the backup dies at the same time, right? So then you lose the updates, basically. You take a little bit of risk for better scalability, right? So that's yes, better scalability plus better performance, of course, right? So the latency is much lower. Okay, read through means so when you do a get key, if you don't have it in memory, we'll call you to load it back from wherever you store it, and put it into the memory, so basically cache it and maintain it from now on. So we also have multi-map. Multi-map is like one key, multiple value, a collection of values. So when you do a get, you get a collection back. So the benefit is that you don't have to get the entire list to add something into it. So you can insert items into the value set as you like. So and then get the entire collection in one shot. Semaphores are very much like logs or countdown ledge. You know the countdown ledge from Java concurrency API. So atomic long, it's like sequence generator. So yeah. So we do provide native Java, C#, C++ lines. REST, we do support REST partially. It's not for everything, but like for the basic operations like put, get, author, take, all that stuff.
Is that what your CLIs use? Is that what your CLIs use it? Or is it goes within the VM that's running the, is it the same VM that's running the node, right?
Well, say it again.
Your CLI, when you were typing the commands, it's not going over the rest, that's already in the VM.
Oh yeah, it's already in the VM. Yeah, it's using the embedded Hazelcast. Yeah. So maybe we should talk about that a little bit. So Hazelcast can be put into the application, and you don't need you can deploy it as part of your application, and you can also connect to the cluster with a client. So it doesn't have to. You can run a separate like Hazelcast cluster and just connect with a client. Client could be a C++, C#, Java, and they do exactly the same stuff, by the way. The logs and listeners and everything. Site. So, so you decide. So if you embed it into your application, deployment will be easy for you, right? So part of your application, just put it into the Tomcat or the Logic and run it. But then the bad thing is that it's part of the application. That means if anything goes wrong with Hazelcast and it will affect you, if everything goes with your application, will get affected by you. So isolation is not nice. So ease of deployment versus the problem of isolation, right? So for those cases, you can choose to run it remotely and just connect with the client.
It would seem you also might have different scalability characteristics for the stuff you're trying to store in, the stuff you're trying to store across how many different nodes and how much data versus the app servers. Question, how would you, I noticed beforehand you didn't mention as alternative something like Redis or Memcached, and I can sort of see intuitively because they're not literally storing distributed Java objects. If you could talk a little bit about how they're a different niche and where Hazelcast might be an alternative to those.
So if you're what you're doing is like pure like put and get, and your expectations are so whatever Redis can do right now is good for you. Then obviously they're designed for that purpose, right? They are designed for storing everything in memory and flushing and asynchronously writing to a disk if you want to, right? So that's what Redis does right now. And Redis cluster is new. I don't know if it is in production yet. But so the current Redis that we know that's in production in many places, it's a single process, and they're just not clustered. So hopefully the guy is working on the cluster version of it, and so we'll see how their cluster is stable and good.
But you would make the case that in a lot of instances where people are using Redis, they could just as well use Hazelcast.
Yeah, we provide more functionality on top of Redis stuff. But what I'm saying is this, like just like we talked about before, like so you look at your requirements and you say, you know what, I don't care about the replicas. I don't really care about this and that. Maybe Memcache is the best thing for me. But you say, and you go with Memcache. But just imagine things like, you do want to use. Let's work on an example. Let's say you're building a game application. You have a game class. It contains all the actions in the game, right? And it's relatively big. So, and you say, hey, and you want to share that game object with many nodes, okay? So you can say, okay, I'll create a game map and and have a game ID and a game object, right? So then the question becomes like, how do you update the game object as the actions come in? So you have to get the game object and insert the new update and put it back, right? So you remember the entry processor, the option. Our entry processor is saying like, don't do that. Just keep everything as object, and push the delta in the form of entry processor, and we'll guarantee the concurrency for you, and just update the big object as the changes, little deltas come in, right? There's no way of doing this with Redis right now. So there's none.
But you said that there's an option that says to invalidate for new caches. So let's say the game object might be in a dozen of a new caches. So what happens if
so for those cases, you would not do that. You would not have a near cache, because what you want is you want to make sure that the game object is stored at one place, and you're looking at or changing the exact one instance. You should not have copies, and you should not have even near caches of the game object.
But I want them for the read-only purposes.
But then, okay, only for the read-only, yes.
But how then Hazelcast will invalidate those objects? Will it invalidate the objects when object is operated on by entry processor?
Good question. So the question is, if the value, so the update is not like a put update anymore. It's an execute on the value. Okay. I have to talk to the guys. That's I mean, my expectation would be this. My expectation would be if the entry is changed, and if you can understand from the replica instance, I would expect map to fire the invalidation messages. So it should be doing it. If it is not, it's a unimplemented bug. Or it's an unimplemented feature or a bug.
So just so you know, we're almost at time here. And I also have like one or two quick questions. Can you speak to a little bit towards like debugging or performance monitoring and stuff like that? What kind of tools or what kind of techniques are available for people that are working in this space? Maybe specifically with the tool or?
Yeah, so let me just promise one thing that I said I'll do, and I forgot. Okay, so what is that thing? So before I forget, let me go over this one very quickly. Remember, so what's open source and what's not that you wanted to know. So it's not clear here, but these blues, the blue colors are actually enterprise features like security, then replication, C++, C#, off heap, management center. These are enterprise stuff. All the maps and queues and everything that we actually demoed, they're all open source. So just put it here, and then we can talk about the testing. So of course we have a crazy JUnit test suite, and as I said, in a JUnit test, we can start multiple nodes and then assert things. But usually the problem, I mean, this JUnit test will find simple stuff. They cannot find the big issues. The big issues can only be found if you run a crazy use case in a real network, like and store tons of data, right? So then you'll see the edge cases. You'll see how really stable Hazelcast is. So we built a tool called Heart Attack. So it gives Hazelcast a heart attack actually, and you implement a business logic like a map with asynchronous backup or with invalidation true, right? So that's a use case. You implement a heart attack for that, and then you run it on a cluster at Amazon. So we use Amazon for testing things like that, and you keep it running for overnight, because a lot of the cases, so hours are not enough really. Like you'll see that even sometimes days are not enough. But you do it long enough. Long enough is like overnight is a good one. So if things can run overnight at a big cluster, big enough cluster with big enough data, then you can feel good about it. It doesn't mean that it's bug free. It's just you can feel confident. That's how we do it. So we have unit tests and things like that, but also, of course, we use CloudBees, for example. We test against all the JDKs, and then so continuous integration and all that stuff. But the bigger test is the heart attack cases.
Right. I guess I meant more as a user of the tool, or when I'm working with the distributed system and like trying to troubleshoot something or figure something out. Like, are there tools that you can recommend, or is it just look at the profilers and stuff that come with the VM?
Heap dump.
Heap dump. Okay.
Thread dump and heap dump.
Okay.
So and give it to us. So we're also building something into the management center that you click. It collects the data inside and creates a zip file, and we can take a look at it. But that's not complete. But that's our eventual goal. So, yes.
We've had someone here a couple times from Puzzle Systems talking about Zing or UGit get some of the benefits of the
Feed,
feed
yeah,
storage.
yeah.
Have you tried Hazelcast with Zim and how does that perform?
I didn't personally do it, no. We should.
It should, yeah, no, absolutely. I was just kind of curious as a way of expanding the size of the memory you have to.
Yeah.
But you probably don't need to if you've got your own storage.
Yeah, there are other things around. I mean, it's recorded right now, so I can't. I'll give my answer after that. So yeah.
So that partition map seems to be very important. How do you make sure that stays correct everywhere?
So oldest member will publish it. So there's only one guy is responsible for publishing it. So whatever that oldest guy said, everyone will accept. So at a given time, it is very possible that I have a different partition map than you do. And for those the cases, as I explained before, a request will come to me and I'll say, you think that I am the owner, but I don't think so, so just do it again. Either he will get updated or I will get updated. Eventually we'll be in the same, we'll look at the same map. But we don't expect everyone to have the same copy every time. So we'll get out of it. Yes.
So I see web sessions there. So do you have some documentation out there somewhere about how to like implement HTTP session?
Oh yeah. So that's exactly what it is for.
Okay.
Yes.
So, are there any scheduling service tools that integrate with Hazelcast? Or have you considered like building in some basic scheduling features for kicking off tasks? Like
we will be implementing scheduled executor service, but if you're looking for like something like Quartz.
Yeah, because like I can set the Quartz, but then in a cluster I'll need to make it cluster aware so it only runs on one node. So I'll kind of need to kind of duplicate stuff that you're already doing.
I don't know. I don't know that.
Reduce the
Well,
task
it has a
and
key,
one
right?
node will
So-
pick it up.
Yeah, I can exactly.
gotta-
I can kind
gotta
of wrap
know.
it up and.
Well, you just put it into a map and say, Quartz lives here.
Yeah, but there are other like annoying things about that. Like,
Of course,
what
we
if?
use threads so that, but you can use like locks and stuff and have it run on every and make sure it only actually executes.
No, but you
one or
use partition awareness, so it will run on a machine wherever that object is wherever the Quartz state object lives. Just put it in a map.
Yeah, but I mean, I was thinking about that particular case, and I was trying to solve one and only one's execution of the scheduled task. That part is still mystery for me, but everything else can be implemented.
I think we should probably call it at that. I don't want to miss your flight, so thank you.